Hey, welcome to the shop. So there are a lot of different kinds of welding out there. I'm going to break down the 4 most common types from a high level so you'll know what you might want to learn or you might want to learn next. Now if you actually want to learn how to do one of these, I've put videos that I've made down in the description below so you can link to those and see step by step how to learn them. But today we'll just talk about what they're good for and how they kind of work. Now let's start off with stick welding. It's also called shielded metal arc welding or manual metal arc welding or rod welding, a bunch of different names, but I'll call it stick welding. It uses these electrodes that look like a stick. Now this is actually an ingenious invention because it solves multiple problems all in one simple package. So the first thing that you have in the center is you have a rod of metal that's similar to the metal that you're welding. In this case it's steel. And I'll connect it to an electrode holder like this, which is an electrical clamp that has a handle on it. And that allows electricity to flow from my welder up through the rod. And then I'll put this other clamp on my welding table, or you can put it on the part you're working on, to complete a circuit. And so you just touch the end of that rod there, and that makes a short circuit and will create a spark that starts an arc. And the arc is where electricity jumps over a gap and creates a tremendous amount of heat. Now when that happens, it melts your base metal, and it also melts off the center of this rod and adds it to it. That's why you get that crowned up shape on your weld. The other thing that happens is this outside coating that's called flux burns off, and it protects that molten metal from the air so that it doesn't get contaminated by oxygen and other things in the air. So it's really genius how that works. Now as you move along, your rod will burn down from long to short, and let's go ahead and do a little demo. So you can see as I'm welding here, the electrode is just maintaining that nice short arc, and that's because I'm moving my hand in closer to the metal as I move along, and it's just, you've got that bright spot where it's really hot, it's depositing that metal in, and it's also burning off that flux and leaving a coating on the top of the weld called slag. Now at the end of the weld here, you can see that slag coating remaining, and I'll go ahead and just remove it with a tool called a chipping hammer. And after I rake that off and clean it up, you can see I have a nice result. So stick welding is really good for a few reasons. One, the equipment is inexpensive. So you can have a basic arc welder like this Lincoln Tombstone Buzz Box, or this is another stick welder that I picked up for about $100 on Amazon that works pretty well also. And so it's very portable, very simple. You just need one of these and some rods along with your safety gear, and you're basically in business. You're ready to go. Some of the drawbacks are that slag coating that it leaves. So I wouldn't use it for like auto body sheet metal. That will be more of a challenge than other processes. I also typically won't stick weld anything that's thinner than about 1/16 of an inch or 1.5 millimeters, though you can if you do it right. But I usually try to avoid that because it becomes pretty challenging to avoid burning through. But it's really good for anything that thick or thicker, especially good for structural things like welding up furniture, trailers, if you want to build a smoker, those kind of things. It's good for all sorts of things like that, just general purpose work and repairs. So really good process. It's used a lot in industry still, especially on the pipeline. Next, let's talk about flux core welding, and it's basically the same process as stick welding in that you deposit your metal through an arc and you shield it with the flux. But imagine taking the stick welding rod and you turn it inside out. So you take the metal and put it on the outside of the flux, and then you wind that around a roll and you feed it with a motor instead of feeding it manually with your hand. And that's what you have here is this feeding mechanism, and you push it through a tube and out a gun. Now some of the advantages here are, one, it's easier because you don't have to worry about striking an arc. It kind of happens on its own when you push the button. Also, you just maintain the same distance and you don't have to stop when your electrode runs out. So it's definitely much easier than stick welding to learn how to do. It can also be done with relatively inexpensive equipment. This is just on a basic flux core welder from Harbor Freight that's less than $200, and there's other similar ones than that. This one I've had for a little while and use it from time to time, and it's worked well. Or you can use basically any MIG welder. So if you know you're going to want to, learn to MIG weld one day or add the gas cylinder to do that, you can get a MIG welder and set it up for flux core now, and then grow into it. So it's really good for that. It can weld, you know, anything from thinner sheet metal all the way up to this one's rated for 3/16 of an inch, but there are industrial processes that weld extremely thick things using heavier duty equipment with flux core process. So it's good for all of that. You still have that slag to deal with, right? So watch as I weld along here. You can see I'm just maintaining a steady distance with my arc between the end of the gun and the workpiece and moving along, and it's depositing metal in just the same. And at the end, after I remove my slag, I got a pretty nice result. Now let's move on to MIG welding. This is the process I use the most in my shop because it's fast to run, it doesn't leave any slag coating, and the reason for that is it doesn't use a flux. So let's look at the equipment here. You can see that there's this roll of wire, and it looks like copper wire, but it's actually steel wire coated in copper to protect it. And that wire gets fed through and out of gun the same way as with the flux core welding, except this time there's a nozzle around the outside and shielding gas, which comes out of a gas cylinder, and that's either carbon dioxide or argon or a mixture of the two most of the time. That gas will protect the weld pool instead. That's nice because you don't get the slag. So it's really good for anything from thin sheet metal. It's great for auto body work. It's great for all sorts of things. Clear up. My machines will run 3/8 of an inch thick material in a single pass, running on 240 volts. So that's with a relatively small machine. So it's good for many things. You can see as I weld along here, I'm just doing a small oscillating motion, and it's filling in that weld, but I don't have that slag on the top. And so after I'm done, it's just really nice and clear and clean. Now, one of the drawbacks to MIG welding is it'll be more expensive than either flux core or stick welding for the equipment because one, the machines are typically a little more expensive, and two, you need that gas cylinder to go along with it. So keep that in mind when you're making your decision, but like I mentioned before, you can start out with just the machine and run it on flux core wire and then get the gas cylinder at some point when you want to. It's also less portable because you need to take that gas cylinder with you. Finally, let's talk about TIG welding, or gas tungsten arc welding, it's often called. And imagine the MIG gun that we had before, because it has the gas nozzle that comes around the outside, but instead of wire feeding out through the center, just put an electrode that won't melt, and this is made out of tungsten alloy, and it's similar to, in a light bulb you'll have a tungsten filament because it can get hot and not melt in an old-fashioned light bulb. And so you can create that arc and concentrate the heat there, and you decouple that from adding metal to it. And so that makes it work really well for precise work where you want to have really fine control. So it's the most well controlled and precise of the processes, though the most challenging to learn. So in order to add that filler metal, you'll just use an additional rod and you'll feed that right into your weld pool. So watch as I run this here. I'm just creating that weld pool, and as I move along, I'm just adding that filler metal right to the leading edge of the weld pool here on this steel weld coupon. And you can use TIG welding for aluminum. It's the ideal process for welding aluminum, but you will need to get a machine that'll output alternating current, or AC, as well as DC, and that'll increase the cost of the machine. So as far as cost goes, there's a gas cylinder similar to MIG welding, and TIG welding machines are in a similar price range to MIG welding machines, with the alternating current options being on the higher end of it. So, you're fairly similar there in terms of price for the machines. And portability, one thing to keep in mind is almost all TIG welding machines can be used to stick weld. So I've taken my TIG welder before and just used it for a stick welding job. So that is an option for you if you get that. Now let's just talk for a second about multi-process machines, and those are machines that are available to do more than one thing. Like I said, pretty much any TIG welder will stick weld also, and now there are machines that are MIG, TIG, and stick, and they'll run flux core also. So you can do all of these with one machine. And just one thing to keep in mind is those typically on the TIG function might be a little more limited in the way that the arc starts. They're usually a lift arc, and we don't need to get into too much detail on that, but it isn't as good as some of the dedicated TIG machines as far as starting your arc. Also, another challenge with those is they will usually only output direct current for TIG, so you won't be able to weld aluminum very well with those multi-process machines. Though there are a few that will output alternating current as well and do everything. So just make sure you know what you're looking for and that it will do what you're going to want to do with it. One last thing to keep in mind with the multi-process machines is your MIG and TIG shielding gas will probably be two different types of gas. So make sure to keep that in mind if you're planning on doing both, that you'd need to purchase 2 gas cylinders, which will increase the cost a bit. So if you want to learn how to do one or all of these processes, check out the videos I've linked down in the description below, as well as some links and equipment reviews that you might want to use. We'll see you next time.